if you hit your OneNote, oh, that's not it. Where'd it go? Lost it already. Oh, we played Semantle. I've lost my OneNote. Where did it go? Where did it go? Anyway, we are going to be doing 3 topics this semester. That was our riddle. Did you guys get a riddle for home group? Our riddle. Anyway, sorry. Our 3 topics: growth and decay. Right? Growth and decay. Followed by calculus, which is, I love trigonometry, that's a top maths, but then calculus, that's even better, so good. And then we're going to finish it off with stats. Yeah, the last couple of years your investigation has been on calculus, so it'll probably be the same this year. We'll see how we go. Right, let me find that. Okay, so we've got little bit of a rundown of our growth and decay stuff. So basically exponential and logarithmic functions. So things that grow really, really quickly and also decay quickly but then slowly. So in order to do that, we're going to just today, hopefully, knock off playing around with surds and our friends, the indices. So back to our index laws, which is that red poster in the thingy. We're going to make sure that we know all of that. So I would strongly suggest that you have a page of summary where you keep all of your stuff, if not 2 pages. So have one page and then sort of go back and forth, or I can give you some paper and you can write it down on that separately, a nice plastic sleeve, up to you. Okay, we're going to go through pretty much chapter 12 and chapter 13. We're just cruising on through. Okay, so if you could rule up today's date and turn to 12a, that would be appreciated. So I would say you have seen these properties already when we were playing with the quadratic formula. Okay, we all know root a times root a is root a squared, so that just gives you a. We are square rooting, so we know the thing under a can't be negative. And this is the one we use to simplify, so we can split. When they're multiplied together, you can pull them apart, same as when we're dividing. And we're just going to play with those a little bit now to simplify. So if you haven't got those on your summary page, please do so. So let's be honest, I'd like to think that you could do these just verbally, but we've got root 11 times root 11. Yep, Tom's given 2 fingers. 11. Root 3 times root 5. Well, you can just stick them under one square root. It's root 15. Do we have to bother writing these down? No. Good. So let's go around. Sask. Yep. It is root 9. What's the square root of 9? 3, right? So the root and the squared cancel each other out. So 3. Okay? Tom? Root 30. Love it. Ooh, ow. Got the hard one. Why is it 4? Everyone happy? Because root 2 times root 2, sorry for those playing at home, root 2 times root 2 is 2, 2 2s are 4. So we shouldn't need a calculator for this. Reminder, you're going to have a test again with no calculator, or it could be parts. So mix it up a little bit. Do calculator and non-calculator. Because you want to be able to do this stuff quickly without really having to stop and look at stuff. And also when you put things in your calculator, you know what the answer will be rather than going, oh, well, I'm just trusting my calculator totally. Okay, so if we look at F, hopefully you realise you can pull out the 3 and the 2, so you times them together and you get the 6. And then you can times the root 2 and the root 2, which is 2. So hey presto, that's how we get 12. Please do G, do H, maybe do the last row. Give you 2 minutes. Better than the other. I'm just saying for H. What are you thinking? When you say square them separately, what do you mean? Yeah, so some people are going, well, this is one of your index rules that you're using. So when you've got A, B to the N, everything in the bracket gets the power because there's no add or take in the middle, right? So some of you are looking at this and going, well, that's 3 squared times root 5 squared, which is 5. Others of you might be taking the squared literally, which means it's 3 root 5 times 3 root 5. Our brains all work, and you get the same answer, right? 9 5s, 45. But again, it's how we see things. Sometimes you're in the index mode. Sometimes you just want to... We're good with that? So when we're dividing, okay, it means you can put the square root all over the whole thing. So this just becomes root 6. We're good? Coops? What's this one? Can't just say 6. Root 6. Yep. Okay. Sorry, I know you guys have to actually write the question and I'm just putting the answer. What a slacker I am. Anybody? It is root 4, but if you left it like that, I'd frown a little bit because that's right. It's 2. Okay? And Amaz, what you going to do with this one? Because you're talking. So what do? Cover up the bottom if you want to, and we're going, what's root 6 times root 10? So you times them together, that's 60. You're dividing by root 12, which means you can put that all under the same square root. So what's 60 divided by 12? Bang, bang, know your times tables. 5. So it's root 5. All groovy? So you sort of did this without even knowing it when we were playing around with this, with the quad formula. But again, when we use technology, it probably takes some of that away, and it's not very nice. All right, who remembers how to simplify surds? Who can tell me, if you can explain it, that would be fantastic. How do we simplify a surd? Hang on. Tom had his hand up before, and then we'll go to you, Dill. So go, Tom. Okay, that's right. Yeah, he just does it. Nike.
Find the largest number that can be square rooted easily.
Okay, so we're looking for the largest square number. Which is a factor. So, what do we mean by square numbers? Al, what's a square number? Good. So 4, I mean obviously 1 is a square number, but that's not going to help us, is it, Triage? Square root of 1 is 1, yeah, good on you. Right, what about 4? Yes, we know the square root of 4 is 2. What's the next square number? 9, 16, 25 and so on, right? 2 squared, 3 squared, 4 squared, 5 squared, 36, 49. You're really hoping it's not going to be the bigger numbers because they have to go into, it's a factor, into these values. So let's take one of my favorites, 48. Right, you look, one of these square numbers, which one goes into 48? Does 4? Now listen carefully. If 4 goes in, always check. Does 16? Okay? We're going to do the example of, oh, we were a bit sloppy and we didn't check that 16 went in. So, is everyone happy? We've gone, okay, it's 4. So this means it's 4 times 4 times what gives you 48? 4 times 12, right? Now, you don't have to write this down. Wait for me to finish because I'm doing it long-winded. We know now that we can separate this to be root 4 times root 12. Yes? And you go, okay, that means square root of 4 is 2. But you have to then look at what's underneath your square root and go, is there still a square number that goes into 12? It's 4 again. Why? Because we didn't choose the biggest one. So would you agree that's root 4 times root 3? What is the square root of 4? 2 2s are 4, so we get 4 root 3. If you had chosen your 16 right from the get-go. So you can get your calculator, 48 divided by 16, that's root 16 times root 3. What is the square root of 16? So you save yourself a whole lot of time, ink, paper, whatever. But if you didn't catch it the first time, you must always check, can I go further with what's inside my square root? Yeah? And of course, if we've got our calculators, that's why it's coming up with 4 root 3. So you can always check. Oui? So take a moment and see how you go with these. Try not to use your calculator. Manners. There is actually manners in mathematics. Tom? Sask? Manners in maths. So believe it or not, you can't have, or shouldn't, have a square root as a denominator. Did you giggle then, Brody? So if I have a look over here, if I go 3 over root 5, it's even, the manners is even in your graphics calculator, because it will not, Jazz, we watching? It will not leave it like that. It writes it as 3 root 5 on 5. So basically, don't have a square root at the bottom. So how do we manage that? Well, when it's like this, pretty simple. How do I get rid of that root 5 downstairs? Times it by root 5. And what you do to the bottom, you got to do to the top. So that's how we end up with the 3 times root 5 upstairs. Root 5 times root 5 is 5. So that's what our calculator gave us. Pretty simple. When we've got not just square root, we've got 1 take root 3 or 2 plus root 7. What are we going to do then? We can't just times by root 3, can we? Because that becomes a root 3, that's 3, we're just making it worse. So we times by a word that you know already. Conjugate. So we times by the conjugate. The conjugate of 1 take root 3 is 1 plus root 3. And of course, what we do to the bottom, we have to do to the top. So this is when your lovely expanding comes in. We times the top, that becomes 2 plus 2 root 3. Now I start to multiply the denominators together, right? And I start going this times this times this, and some of you should be going, but why are you doing that? Because what should you recognize there? 1 take root 3 times 1 plus root 3. It's difference of 2 squares, that's right. So 1 times 1 gives you 1, right? You get 1 plus root 3, then you take root 3. The middle bits cancel out. Negative times a positive is a negative. Root 3 times root 3 is 3. So I can tidy this up. Plus 2 root 3 all over minus 2. Can leave it like that. 2, 2, 2. Now I'm regretting actually timesing that 2 out. I should have just left it as it was. Because what can I do? Can cancel. So 2 divided by 2 is 1, so it's minus, so it'll be minus 1 minus root 3. I've divided each of these by minus 2. Agreed? Just in brackets over there. These used to be great little test questions. You'd have to do it. Oh, hello calculator. How I love you so. Because if we pop it in, 2 over 1 take root 3. Yes. So if you get a question like that, it would be show you're working or show every step. And you would have to do it, but you can always check on your calc. So know that your calculator does do this stuff. Okay? So maybe we'll save indices for Thursday. Come full of sugar. What is it that I would like you to finish? Well, okay, so homework, exercise 12A2. That's what we're finishing off now. 12A3 is this stuff. And then 12b is starting exponentials. Just look at it. Look at using a calculator for the first few. It's just warming up. If you don't look at it, I'm not going to be that annoyed.